Hi, everyone, and welcome back. We're going to go into Chapter 2's recorded lecture now. We're going to look at some specific things related to doing research in psychology, applying the scientific method to study some of the things that we talked about in the first chapter, but specifically we'll be focusing on behavior and processes. That's where we are in modern psychology. And then, of course, when it comes to doing research, this oftentimes involves measuring behavior using various tests and analyzing our measurements using statistics. And there are some limits and issues when it comes to doing statistical analysis as well. This is going to be a pretty brief and shallow coverage of the all of the issues and statistics. If you are a psychology major, you have a couple of statistics classes you'll be taking in the future. And otherwise, you can take stats classes and learn all the ins and outs of that sort of stuff here. So let's first start with some of the basics of, of doing psychological research, which is focused on the issue of observation, which is something we touched on in the first unit. We talked about the issue of empiricism, right? Empiricism is defining knowing through observation. It's a philosophy about we can only know what we can observe. And science is defined as being an empirical enterprise, right? Empirical science means a science based on observation. Using the phrase empirical science is perhaps a bit of a redundancy because science itself implies that we are observing, that we are using empiricism. So the question then becomes, and this is what we talked about before, what can we observe, right? What can a psychologist observe? Because when we talked about this in chapter 1, we were talking about consciousness and experience and people's feelings and their ideas and their thoughts. Can we really observe those things? And that becomes problematic, right? So we try to eliminate talking about these more abstract ideas of consciousness, but we still assume and we still think that there's something actually happening inside the minds of other people. And if we can't observe them in any direct sense, that there might in fact still be a way that we can get at them, right? There might be still some way that we can get at them empirically, right? So how do we do that? And this is where we need to talk about what's called the construct variable problem in psychology. So all of the things that we really want to study are things that we can't really observe directly. So we can say that, let's talk about something pretty basic, pretty uncontroversial, memory, right? So memory is what we're going to call a theory, right? What I can observe is the fact that people can appear to remember things. I can give them a list of words to memorize. They can let them look at it and take it away. And they can then tell me what those words were. They appeared to have stored that information inside of them. What I have observed is merely their reproduction of the list. And then I use theory to explain, oh, there must be some mechanism inside of that person that enables them to store that information, retrieve it later, and reproduce the list. So memory becomes a theoretical idea that I use to explain their behavior meaning their ability to actually reproduce the list, which is the thing that I can, in fact, directly observe. So what we're going to call memory here is, instead of necessarily calling it a theory, though that is technically correct, we also use the phrase construct, psychological construct, right? So memory is something that is inferred to exist as a construct to explain what we have observed. And now, in order to actually try to measure the construct, we need an official measurement of it. And that's called the operational definition, right? So in the case of a memory test, for example, if I give someone a list of 20 words to memorize and let them spend 10 minutes looking at the list, and then I take it away from them and I wait some period of time and ask them to reproduce the list, the percent correct would be my operational definition of their memory. And that is called a variable because it's something that can vary over time. One person may be given the same test multiple times and over different responses may remember more or less of the list, and other people may remember more or less of the list as well. So that's a variable, but it's all meant to measure the same underlying construct of memory. And this is one of our key things in psychology, right? So we have here a list. This is just a very small list of 4 possible constructs along with 4 variables that we could use to measure them. So as I had mentioned, memory could be defined in terms of a variable, an observable variable. And of course, that's the key issue here, is that variables need to be defined in things that are observable, whereas the constructs may not be. So as we said, scores on a memory test, right? Just a % correct. How many words could you remember? Historically, that measure is actually not even very popular. I'll briefly talk about an alternative called savings time. Let's say I have a really long list of words that I want someone to memorize. 50 words perhaps, right? That's really long. It's a big, long list of words. So you're going to have to, if you really wanted to memorize the whole thing, it might take you a long time to do it, right? Let's say it takes you 2 hours of studying that list, going over it back and forth, testing yourself and so forth before you're actually able to reproduce the test, or the list from memory without looking at it. So 2 hours of total study time to memorize this really long list of words. And now what happens is I could wait a day, right? And I've got this research subject who has spent their 2 hours to memorize the list. And rather than testing them immediately now, although I've done that just to show that they've memorized the list, but now I'm going to wait a day and I'm going to bring them back to the laboratory and I'm going to ask them to reproduce the list again. And they're probably not going to remember everything, right? So I see that they have now scored less than 100%. But what I'm actually going to do is I'm not going to make a big deal about what their exact % correct was, so much as that what I'm going to do is I'm going to ask them now to relearn the list. So I'm going to give them the list of words again. And I'm going to say, I want you to start studying this again until you can remember 100% of it. Now on day 1, it took them a whole 2 hours to do this. But on day 2, it might only take them 30 minutes, right? So now they have saved some time, right? Day 1, it takes 2 hours, 120 minutes to learn the list. On day 2, it takes only 30 minutes to learn the list. So now they've saved an hour and a half or 90 minutes, right, off of their learning time. And that's a measure of how much carries over from day 1 to day 2, right? And so you could do something like measure savings time as a function of time since the initial study period. So if they study on day 1 and it takes them 120 minutes to memorize the list, you could say, what's the savings time if I wait 1 day, 24 hours? What's the saving time if I wait 48 hours or a week or a month, right? And then you might find that the saving times is less and less the longer that interval is. And that's seen as a more reliable measure of how much memory was really there the whole time. Emotion is another one, right? So oftentimes we think, oh, can't I just judge someone's emotion by looking at their facial expressions? Well, maybe, right? But how objective is that really? And that's another issue, is that we really do want to be concerned with the objectivity of our variables. And that relates to something that we're going to be concerned about here with validity. That is if I look at someone and I determine that they are smiling, and I conclude from that they are happy, there is some concern there that in terms of it being not objective is that sometimes smiles are ambiguous, right? Is that person really smiling, or is that just their natural facial posture, right? And so some people smile much more blatantly, I guess you could say, than others, right? Some have a much more subtle smile. So there might be some difficulty. You know, I could look at a person and say, I think that person's smiling, and another person might look at them and say, I'm not sure. I don't know if that's really a smile or not. So there's a subjectivity to that. We don't want that, right? And of course, we could also worry about other things, such as the fact that I can just fake a smile. And I don't know that we could always tell the difference between a fake smile and a real smile. So therefore, there might be some deception happening here. So that's maybe not a good enough scientific variable as a way of operationally defining emotion. Likewise, the same issue goes with self-report. I could just simply ask people to tell me what emotion they're experiencing. So that could fall, victim to the same kinds of deceptive things. How do I know that my participant's telling me the truth or not? There's ways around this. I could attempt to bury the question in a list of other questions. So I could have, let's say, imagine I could create a survey that has 5 questions on it. And each one of those questions is a way of asking someone to report about their current mood or their current emotional state. And I'm concerned that if a person knows that I want to know their mood, that they might lie for some reason. But what I could do is I could bury those 5 questions in a longer list of another 50 different questions that are all completely irrelevant, right? So now the person is taking this 55 question survey, and the questions don't seem to be related to each other in any way, and they have no idea why they're taking the survey. It's just a bunch of seemingly random questions. And so they go through and they assumingly now answer it honestly. And then what I do is I get the reports on all that, and I take the 50 irrelevant questions and I throw them away, and I just look at their answers to the 5 questions that were the key questions about their emotion. And that might give me a slightly more accurate and perhaps maybe more truthful report, if for some reason I had reason to believe that they might not want to tell me the truth. And who knows why exactly. But if I'm disguising, the point here is that it's possible to disguise the purpose of a survey sometimes. And if there's a reason why someone would change their answers if they know the purpose of a survey, then it is possible sometimes to cover that up. Or I could try to move away from these more subjective self-report kinds of things of asking people to either fill out a survey or just tell me their feelings by other measures. Is it possible, for example, that there are physiological measurements? Could I hook someone up to an EKG to measure their heart rate and blood pressure? Could I hook someone up to an EEG, which measures brainwave activity, and use those as a way of detecting someone's true emotional state, regardless of what their facial expression is or their subjective self-report? Well, not exactly, right? There are not unique physiological markers that correspond to every possible human emotion, but nevertheless, there are certain physiological indicators of arousal and stress, and that could be used to distinguish strong arousing emotions from milder ones, perhaps. It remains also possible that movement may betray emotions, right? And there's, there's a long kind of pseudoscience associated with the concept of body language, right? But this goes a little bit beyond body language, to suggest that if I actually use some sort of movement tracking devices that can record the velocity and acceleration of someone's hand movements, that might actually be able to distinguish certain kinds of emotional states or motivations behind someone's actions. There's a little bit of evidence to support that. Let's think about personality, right? So again, what is personality to begin with? Personality refers to this idea that people tend to be fairly consistent in their behaviors over time, enough to the point where you think, oh yeah, that seems to be just some aspect of who they are because they always act that way. This person is always sociable and outgoing and very demonstrative with their emotions. So I'm going to say that that's a personality trait that they have, right? Because it's consistent. They seem to always be that way. And when we say we get to know someone, oftentimes what we mean is we're getting to know their personality traits, right? We're getting to know who they are. But how do we study personality scientifically? I can't just follow someone around and get to know them very closely as a psychologist and just learn their personality by interacting with them and observing them over long periods of time, for years or months or however long, right? So what we do is we develop surveys, right? These are, again, self-report questionnaires. There's a list of statements or questions that relate to personality traits, and I'm asking, tell me, do you believe that this description, so it could be a description such as, I find myself to always be the life of the party. Now, is that a statement that's true about you, or you find that that's a statement that's not true about you, right? And so people will go through and they will report whether they think it's true or not true about them, and then we can look at their responses on all these questions and give them a score that says, oh yes, you rate highly on the extroversion scale, and maybe you rate low on that, which would make you an introvert. Of course, we still worry about this kind of stuff, such as are people telling us the truth? And two, how good at people are actually accurately reporting that, right? They might think that they are extroverted, but maybe they're not, right? And you know, how do we know for sure if someone is really, you know, good at this kind of introspective self-analysis? And people might vary in that. And then, of course, another tricky thing, intelligence is another thing that's very difficult for us to study and understand. And we've come up with tests of it, right? So-called IQ tests. And that's got its own big history there. And the nature of these tests have changed quite a bit over the last 120 years. And we still need to be concerned about what it is we think that we're actually measuring when it comes to intelligence. What is intelligence in the first place, right? And that factors into certain kinds of issues, such as my own views of what I think intelligence is going to affect what kinds of questions I would put on a test of intelligence, right? Is a measure of spatial reasoning an appropriate kind of thing to include on intelligence test? What is spatial reasoning? For example, you might have done something like a mental rotation task before, where you're looking at these weird three-dimensional block-like shapes that are kind of twisted and, you know, creating these weird kind of weird Lego shape type things, and they're oriented in different positions, and you have to mentally rotate one of them or both of them to determine if they're actually the same shape seen from two different perspectives or whether they're different. And that's a measure of your spatial reasoning ability. Is that a component of intelligence? If so, then you would probably want to include something like that on an IQ test, right? But otherwise not. What about reaction time? If I present a stimulus and I just want you to respond as quickly as you can detect it, is that a measure of your intelligence? Well, people have considered this in the past. It's no longer part of an intelligence test, but it used to be. So how do we know which ones of these kinds of tests and questions and items are actually appropriate for an intelligence test, and which ones are actually more appropriate for a personality test? That's another question too, really too, which is what kinds of aspects of a person that we might consider to be some enduring, stable part of them is because of it's their personality versus it's their actual intelligence. Personality intelligence we would think of as being two independent constructs, right? Two completely different, unrelated aspects of a person. That actually remains to be seen. There is some debate even that personality and intelligence may in fact be related to each other. There's a personality trait called openness. And personality theorists like to consider openness to be a personality trait, but then there are other people who say that openness is something that correlates with your intelligence and your IQ, and that's really not a measure of personality, it's something else. And that remains, again, just to be a debate. We don't have an answer to that, not a concrete answer to that. So when we're getting at these kinds of questions, when we say that we are trying to study these constructs like intelligence and personality and memory and emotion and whatnot, we're trying to come up with a good variable as a way of measuring it. And what we're concerned about here is what we call the validity of the measure. Validity is a question related to whether or not this variable measures what we're actually trying to measure. Does my IQ test actually measure someone's intelligence, or does it measure something else, right? For example, we tend to think of someone's intelligence as being something that's independent of their actual educational achievement. The idea, of course, is that you could be a genius. You could just be a raw genius. You could just be as smart as Einstein, but you never went to college and you never got a doctorate and became a famous physicist, right? That doesn't mean that you're not intelligent. It just doesn't mean that you didn't get all of that educational stuff. So you're not going to necessarily use that intelligence to discover the laws of the universe in the way that Einstein did, right? But in theory, a well-designed intelligence test or IQ test would be able to identify such a person and say, oh yeah, despite the fact that you don't have all of the fancy education, you're still actually quite intelligent, just as intelligent as Einstein, right? because again, what we're thinking here is that someone's raw internal intelligence is not the same as just getting an education and learning things, right? Intelligence represents more about capacity to learn, capacity to do things, right? Not so much what you have learned in terms of actual achievement. It's more about aptitude than achievement, right? What you can do more than what you actually have already done. So if I have a poorly designed IQ test, it might be a test that measures the kinds of things that you're taught in school. And what you might find is that someone who has a lot of education, who's been to school, has learned all those things, and then scores higher on the IQ test because they went to school. Whereas for someone who didn't go to school, they didn't learn those things, so therefore they're not going to score quite so well. But that's not what this test is supposed to be getting at, is whether you actually went to school, right? So that would not be a good IQ test if it was measuring those kinds of school-specific kinds of things. You know, you could only succeed on this test if you actually went to high school or you actually went to college, right? Not how you want to do a test for intelligence. So this is a question of what's called construct validity, right? Because to have construct validity means that your variable, your measurement, is measuring the construct that you're trying to measure. You're trying to measure intelligence, but instead you're actually measuring educational achievement, right? It's the wrong construct. You're trying to measure X, but you're really measuring Y, right? So what we worry about, especially in psychology, is, and maybe more than any other particular science, is are the measures that we have actually valid, right? So that's called the validation process. To validate a measure means to try to determine whether it's actually measuring the right construct. And there's a lot of ways to do that. In fact, maybe we don't want to go down that rabbit hole, but there are things such as determining whether or not, let's say, intelligence is supposed to be something that's pretty constant across your lifespan and over time, right? So if I give someone an intelligence test and then I wait a year and I give them another intelligence test, I should expect them to score about the same. Maybe not identically, but pretty similar. But if suddenly their IQ took a big swing up or down by 30 points, I might think, did the person change that much, or really is it something about the test that's just not valid, right? Their intelligence was actually constant, but their test is measuring something else that's actually a little bit more variable over time. Likewise, we could also talk about things like predictiveness, right? So intelligence is supposed to predict something, right? If I think that you have a high IQ, it should predict that you should be successful in school and would be capable of graduating high school or college with a high GPA. But if on the other hand, it doesn't work to predict such things, then maybe the problem is not with the idea of intelligence, but it's the problem with the test itself, right? It's not measuring intelligence correctly. There's all kinds of other ways. We don't really need to go down that rabbit hole of how to determine the validity of a measurement. That's for a whole semester of research methods. But the idea is that's one of our major challenges, right? Now, once we assume that we have some pretty good, and I mentioned we know that we have kind of revised IQ testing over 120 years. So that's part of this idea of improving and the validity of our measures. The same applies to personality tests and all the various measurements that we have. Let's assume now for the moment that we can work on the assumption that the variables, the operational definitions for the constructs, are valid for the most part. And let's move on to something else, which is how do we understand and study these constructs, which I had previously mentioned are really theories, right? We can't observe memory, but I use memory, the construct, as a theory to explain a certain phenomenon that I observe, both in real life of human behavior and in the laboratory of measuring performance on memory tests, like using savings time. And the same applies to intelligence and personality. I can use that as a theory, personality traits especially, to explain both regular, ordinary, everyday observations of the fact that people tend to be predictable, and I get to know someone and I can understand and predict their behaviors, as well as the fact that when I administer personality scales and surveys in a laboratory setting, that I can use that to explain and predict their behavior as well. So this is a scientific problem. And if you remember back in chapter 1, we talked about different philosophies of science positivism, which is to say that something can only be scientific if we can observe it. Theories are potentially problematic because theories, by definition, are more generalized statements that go beyond the observations. So a purely positivist approach to memory would focus just on the mere fact that people can report what it is you've asked them to memorize, right? They can actually perform on a memory test. But the logical, so the theory of memory then that comes from that would be something that is going beyond that to then to invoke this more generalized idea that there is some kind of storage system inside the person. And in fact, maybe there are different kinds of storage systems. And so in psychology research, we have concepts like short-term memory and long-term memory, right? Those are two different kinds of memory systems that have been theorized to exist based on the fact that there appears to be two different kinds of memory performance, right? There's the kinds of memory that we can keep active in our minds over the short time period. And then there are memories from things that have happened to us from 20 years ago, or well, if you're 70 years old, maybe you can remember things from 60, 65 years ago, right? So really old memories. And that seems to be different in many ways. And I will call those things long-term memories. Or even just remembering something that happened to you a few months ago is still maybe a long-term memory. So how do we justify these theoretical statements about different memory systems, even if we can't observe them? That's where logical positivism comes in. And so we have to define now a scientific method based on logical positivism that allows us to justify these kinds of theoretical statements as having scientific value. And this is kind of my basic overview of the scientific method here. So we start by making our observations, right? We start by observing the fact that when I administer memory tests to people, that they can consistently report what they have been asked to memorize. And I can also observe other patterns, such as the fact that the amount that they remember or the amount of savings times declines the longer I ask them to wait before I ask them to recall this information. And so I make all these observations, and so then what happens is that we create a theory using inductive reasoning, inductive logic, and that's defined as reasoning from the particular to the general. So in this case, what that means is that every observation I make about a person in the laboratory or in real life, in terms of their memory skills, those are all particular cases, particular instances of memory performance. And I take all those observations, and then I generalize to say, there must be some common theme here across all of these individuals, that they all have some kind of a system that enables them to store this information. And I'm going to give that a name. I'm going to call it memory. And that's my theory. I have now generated that theory as a consequence of all of the particular observations of human behavior. But now, in order for this theory to be considered scientific, it has to meet certain criteria. And one of them is that it must be able to make predictions. So I might add to my theory of memory that memory is something that is not necessarily fixed and permanent, but it could fade away over time, maybe. And that might mean that if I ask a person to memorize a list of words and I wait 24 hours, that some of it has faded away and it has to be relearned. But if I wait a longer time period, such as 72 hours, then maybe a little more has faded away. Because again, this fading process is something that just happens gradually over time. These are all theoretical statements, right? I'm just speculating that memories fade over time. And as speculation goes, by itself, that's not scientific. But the fact is that such speculations can actually turn into more formal predictions. And I could actually say, all right, if that is true, I could then predict something. That if I actually do a controlled experiment where I have people memorize this list and then I controlled wait specific times, 24 hours, 48 hours, 72 hours, then over time what's going to happen is I should see a very specific pattern of forgetting occurring. That's deductive logic here, because what I've started with is I started with that more general claim, and that's the deductive reasoning is the opposite of inductive reasoning. Instead of reasoning from particular observations to the general statement, that's induction. Deduction is taking that general statement and generating if-then statements, particular conclusions. So I would, as I said already, if memory traces really do fade away over time, then I should be able to do this controlled test to specifically manipulate time after recall and measure performance on the test. And I should see a pattern there that makes sense based on the theory, right? So then when we say that a theory is testable, that's what we mean, is that we can use deductive logic to, and hence why this is called logical positivism, because now we can derive this hypothesis deductively from the theory, and then we can test the hypothesis, right? We can actually do that research and see if the findings actually support what was predicted. In which case, typically what we would find, hopefully, is yes. In which case now we're able to assimilate those observations into the theory, helps us gain some confidence that this theory is correct. Sometimes, however, we might find some unexpected results, which might cause us to have to go back, maybe not throw out the theory entirely, but maybe just modify it a little bit, shape it, improve it. And this is actually a lot of what psychology is about. We call this theory building. For example, one of the key theories in psychology in terms of personality psychology is the idea of the 5-factor theory, or the 5-factor model, or the Big Five theory. The idea is that there are 5 personality traits, and you can use the abbreviation OCEAN to remember that. So O for openness, C for conscientiousness, E for extroversion, A for agreeableness, N for neuroticism. That has come about through theory building, because a long, long time ago, a researcher named Gordon Allport went through the dictionary, and he found every single possible word in the dictionary that could relate to a description of a person, and therefore could potentially be a personality trait. And he found thousands of words. Now, obviously, we don't believe that there are thousands of different personality traits, but what Allport did is called lexical analysis. What he did is he took some of those words and he realized they're actually synonyms. They mean the same thing, right? So therefore, they don't actually represent, like if there are 15 different words that were all synonymous with each other, they don't measure 15 different personality traits. They really measure one personality trait. So you'd be able to reduce it down from all of those different thousands of words to a much more smaller finite list. And that process has been refined using various statistical procedures over time and by giving different personality tests over time. And over time, we've been refining how many different traits. And people argue, they would say, oh, no, there's 16. Oh, now we're going to improve it to 5. Some people say 6. Some people say 3, right? But that's the process of theory building, is to try to figure out what is personality in and of itself. How many, is it a set of traits? If so, how many different traits are there? And over time, we improve our theory through this way, by doing new tests and getting new findings. And we settle on a particular approach. And currently, again, that 5-factor theory is the most popular one. This is called normal science. This is how science is supposed to work, is that we have the theory. We're going to keep testing it. We're going to keep refining it. And every observation, every new experiment that's done helps us improve it and make it better. But also another aspect in the philosophy of science is that sometimes we get completely brand new ideas, things that revolutionize the field. So these are sometimes called scientific revolutions, though more common in the philosophy literature is called a paradigm shift. And what this means is that sometimes brand new discoveries that we had never considered before. In the history of science, this has been things like Louis Pasteur's discovery of yeasts and other microorganisms that cause spoilage and ultimately of disease and infection. And before that, we didn't know what caused food to spoil, and we didn't know what caused communicative diseases, right? Communicable diseases. So there was all kinds of old-fashioned ideas that suddenly got discarded because we could just throw all that stuff out and say, no, it's yeast and it's bacteria and it's viruses, right? And once we had that, that was a revolutionary change to how we did medical research and all that kind of stuff. Certainly Einstein, I mentioned Einstein earlier, and his ideas about quantum physics and relativity theory fundamentally changed in many ways the way in which we view the universe and the reality around us. In psychology, we haven't necessarily had a true scientific revolution or a paradigm shift. The closest is cognitive psychology. So if you go back to the list of all of the different schools of thought we covered in chapter 1, structuralism, functionalism, behaviorism, cognitivism. In the 1950s, sometimes there's a phrase called the cognitive revolution to describe what happened when the cognitive psychologists all kind of just took off and they're like, behaviorism's wrong, we got to throw it out and replace it with cognitive psychology. And in many ways, that wasn't necessarily a true paradigm shift. They were just basically saying that this behaviorism stuff you've been doing for a couple of decades, no, throw it out. We're going to go back to some of the other older ideas. But there were some new things that happened then. And in particular, in the 1940s, digital computing was invented. And that was a brand new thing. It's a brand new technology that works in ways different from any other machine that's ever been invented. And along with that came new ideas about information and how to quantify and measure information using bits, and how to think about information transfer in terms of bandwidth, which is measured in bits per second. And could we take some of those ideas about how digital computing and processors and computation and apply that to the brain, right? And to human psychology, and treat brains as if they might be digital computers with input, processor, output kinds of systems? That became a hugely popular thing in the middle of the 20th century. It remains pretty influential in cognitive psychology, though there are certainly a lot of current critiques on that. But if anything, then that was somewhat revolutionary, right? That completely brand new technology that gave us a brand new set of metaphors that we might try to use to explain how brains work. And it definitely shifted the way psychology research was done for several decades. Now that we have a theory, though, we still need to make sure that we can distinguish it as a scientific theory from just any ordinary speculation about human behavior, because that's what people do all the time, right? We're all to some extent naive psychologists because we like to just speculate about behavior, right? That is, we observe other people all the time. We observe our friends and family members, and we speculate about why they do what they do. So those are theories of other people, but that's not scientific psychology, right? Because why, right? Here is the list of characteristics of a scientific theory. First of all, a good scientific theory should account for all the data, right? Sometimes when we generate our own naive theories of human behavior about our friends and family, we're not really accounting for everything about the person, just the parts that we remember and the parts that we notice, right? Sometimes this is called the confirmation bias, right? That I have a belief about a person, that I believe that they are a particular kind of personality, that they're introverted or extroverted maybe. And if that's my belief, that can actually influence the way I perceive that other person's behaviors. Whenever I observe an instance that is consistent with my belief, I notice it and I say, look, there's more evidence that I think that I'm right. This person really is an extrovert, let's say. But if there might be a time where they're actually behaving in a different way, maybe I don't even really attend to it, right? I don't think about it, I don't notice it. And I only really pay more attention to the times that their behavior confirms my beliefs, right? So that means I'm not being scientific here because I'm not accounting for all of the data. I'm not accounting for all of their behavior. So a scientific theory needs to be a little more objective than that, right? And not just subjectively pick and choose which things it's going to account for and ignore all the other stuff. As I have described, it needs to make predictions and be testable, but in particular, it needs to be falsifiable. And that's a crucial thing here that goes beyond just being able to generate a prediction and test it and say, okay, that's exactly what we expected. Does that prove the theory is true? And the answer there is no, because there could be another alternative theory out there that might make the same prediction. And so the original theory we're working with might actually be false. And it was just kind of lucky, perhaps, to have made the prediction that was upheld. So in order to be really considered scientific, a theory needs to be falsifiable, right? It needs a way to be proven false. So for example, my theory about memory and decay of memory, that's a falsifiable statement because I'm making the prediction if I wait longer and longer and longer, people's memory performance should decline worse and worse and worse, right? And if that did not actually occur, then my concept of memory decay would be falsified, right? I would say, no, that's clearly not the case, right? That's a falsifiable statement. I think I had mentioned in the chapter 1 notes, talking about Freud, that one of the reasons why Freudian theory is not scientific is because it's not falsifiable. It doesn't make predictions about the future, really, right? It only explains things after the fact. And that's our next point here, is that a theory should not be in the business of only explaining phenomenon after they occur, because you can turn that around and you can rationalize it any old way, right? In Freudian theory, if a person, as an adult just emerges with an anal retentive or an anal expressive personality, that phenomenon is explained only after the fact. It's rationalized by talking about their early childhood experiences with authority and discipline and probably toilet training. But no prediction is made about children and what would exactly happen if they experienced X, Y, or Z when it comes to discipline and authority. And another concern here is that sometimes you could have two theories that both make similar predictions, and therefore would be difficult to test them apart when it comes to actual experimentation. But one of them might be a very simple, elegant theory that doesn't make a lot of extra assumptions and complex explanations of things, and the other one is really complicated and convoluted in its logic. And so we would say that the first of those theories is parsimonious. It's simple and elegant. The other one is complex and ugly and so forth. We say ugly here just in the context of a simple, elegant solution always seems to just be more appealing, right? Freudian theory is another good example of lack of parsimony, because Freud uses a lot of complex explanations talking about instinctual unconscious needs and hidden unconscious processes like frustration and retaliation and a reaction formation and defense mechanisms and all kinds of complexities to explain our personality traits. In contrast, something like behaviorism, much more simple. So you might be familiar with a famous experiment done in the I think it was 1913 or 1920 maybe, get it wrong. Yeah, 1920, by John Watson and Rayner. They did the famous Little Albert study where they took a 10-month-old baby and they used Pavlovian style conditioning techniques to make him afraid of a rat. What they would do is they would place the rat in his lap, and then they would take two metal bars and bang them together to make a loud sound, which activates a startle reflex, so that the child began to associate the rat and the presence of the rat with being startled. And so now, after having gone through those trials, all the child needs to do is to see the rat, and he's going to start crying now that he's associated that startle response. Watson was later asked, does this possibly mean that the child would grow up to have a phobia of rats? And Watson replied that yes, it could happen. He didn't know for sure because he didn't actually track what happened to little Albert. But he speculated that that if it was possible that this child really did develop a phobia of rats, and that as an adult, he may have sought out a Freudian type psychoanalyst to help him deal with this phobia of rats, that the psychoanalysis would likely come up with some convoluted explanation of the fear of rats based on some repressed psychosexual trauma that has to do with pubic hair. That was Watson's explanation. And we can see that that is a obviously convoluted, complex, and most likely unwarranted answer given the simplicity of Watson's explanation, which is that it was simply just a conditioned response based on the learned association between the loud sound and the rat. So there you have it, right? The behaviorist explanation is far more simple and parsimonious than a Freudian type explanation. Now, why is falsification so important, right? The idea is that theoretical statements like these are difficult to prove true, maybe even impossible to prove true, though it is possible to prove it false. For example, I could say that all ravens are black. That's a general statement, right? Which makes it a theoretical statement. And what I mean is that all ravens are black because every raven that I have observed is black, right? So it accounts for the data, and it does make a prediction, right? It makes a prediction that if I, in the future, observe a raven, I should expect it to be black. And every time I observe a new raven and I see that it is black, that adds more confidence in the theory, but does it prove it to be true? Is it possible that somewhere out there somewhere is a non-black raven hiding somewhere that is yet to be discovered? Well, it is possible, right? And until I observe that, I believe the theory to be true, but I can't absolutely prove it true. But it can be proven false, because if I keep on looking and eventually do discover someday the non-black raven, well, I have now falsified the theory, right? So that's a scientific statement to say that, because it is making a prediction, is counting for the data, and it is in principle falsifiable. Whether it ever is falsified is a different question, but at least it could be falsifiable. Whereas Freudian theory doesn't make such a statement like that. It doesn't say, for example, all strict toilet training leads to anal retentiveness, right? Because it could also be the case that strict toilet training leads to anal expulsiveness, right? So it's not falsifiable. But now that we have a theory, and this theory can be testable, falsifiable, and it makes a hypothesis, we have to be able to test our hypothesis. And what I want to do here is I want to stop the video here, because I want to move on from talking about the broad theoretical stuff to actually doing hypothesis testing, which is actually doing psychology research. And let's break this up into a smaller set of notes, so that we'll stop it right here and come back to this after you take a break and think about the first part.